Hey team, today we're going to be going ahead and doing antiderivatives. So we're going to be solving some questions on integration. And I'm going to be doing them for the very first time, these questions. So feel free to go ahead and solve them as I'm solving them, and then we can compare our answers. So I've got the questions here on my screen. Okay, so the very first question is to integrate the indefinite integral of 18x to the power of 5 plus 12x plus 10 over the square root of x minus 3 dx. Okay, very first thing that I really want to clarify is that when we have an integral, we can use the constant multiple rule. So let's say we have to integrate the function k f of x, right, where k is just a constant. Let's say it was 3x squared here. What we can do is simply just write it out as 3, or we can write it as k times the integral of f of x. Okay, so we're gonna bring this concept into this question here. So I can instantly see here, I've got 18 would be my k. So what I'm going to do is it's going to be 18 times the integral of x to the 5 dx plus 12 times the integral of x dx. Okay, and then I'm going to do plus 10 times the integral of x to the negative 1/2 dx minus 3 times the integral of basically 1 dx. Okay, so, or we could have just also left this as the integral of 3 dx. Now here, right, x, the square root of x is equal to x to the power of 1/2, and now because it's on the denominator, it's the same as writing it as x to the power of negative 1/2. So now we just go ahead and we can integrate this. So integrating, the formula for integrating is super simple, right? So if we have to integrate x to the power of n dx, then all we're going to get is x to the power of n plus 1 over n plus 1 plus our constant multiplier. Now, or plus our constant, sorry. Now, the reason why this constant is always here is because when we differentiate any value and we've got a constant, that constant disappears. So integration is the opposite of differentiation. So if we have, let's say, 3x plus, or let's say we have y is equal to 3x, and we want to differentiate this, simply, that's just going to be 3. Now, let's say here actually it was 3x plus 4, right? Then the first derivative would be 3. Now, if we have to integrate 3, then that is very simply going to be, or 3x. So integrating 3, that's simply going to be 3x plus c, right? Right, this is because this here is the same as writing 3x to the 0. And so when we integrate, we're going to add, so it's going to become, right, so this here is the same as writing 3x to the power of 0, right? Because anything to the power of 0 is just 1, right? So here we're integrating 3 times x to the power of 0 dx. And what that means, so we're going to increase x to the power of 1. So the power is going to increase by 1. So it's going to become 3x to the power of 1 over 1 plus c is equal to 3x plus c. Now, the reason why it's this constant c is because this 4, this could have been 10. It could have been 100. We don't know, right? So whenever we integrate, we add that c, unless, of course, we've then got our limits, right? And this is something more advanced. If we have our limits, then we can actually find the proper equation. So we're coming back here. We have 18 x to the power of 5 dx. So the integral of x to the 5 times 18. And if we go ahead and we use this formula, we have to add 1 here. So it's going to just be 18 lots of, so x to the power of n plus 1. So x to the power of 6 over 6, right? Plus 12 times x to the power of 2 over 2 plus 10 times, so negative 1/2 plus 1 is going to be positive 1/2 over 1/2 minus 3 times x over 1, right? It's that same thinking that we had here. It's x, an imaginary x to the power of 0. We add 1, then it becomes x to the power of 1, and divide by that 1. And now here we're just going to add our constant, right? We have to remember that we always add that constant. So now we can just go ahead and simplify. So this here is just going to become 3. So it's going to be 3x to the power of 6 plus 6x squared. Here we've got our 0.5. So that is going to simply become, well, we have to essentially imagine, well, this is going to be 20, I believe, right? Because it's the same as writing 10 over 1/2. Yeah, which is 20. So plus 20 times x to the power of 1/2, which is the square root of x, minus 3x plus c, okay? And so that there is going to be the integral. All right, now I'm quickly just going to check. So 10 divided by 0.5 is 20. Yep. All right, so let's go ahead and enter that answer in. So we have 3x to the power of 6 plus 6x squared plus 20 times the square root of x minus 3x plus our constant c. Okay, now let's check that. Awesome, and that is correct. Great. Okay, and the next question is a little bit more complex. So they're asking us to find the integral of 15 sine x plus 3 cosine x plus 12 e to the power of x minus pi dx. Okay, so now this is getting a little bit more complicated, and we have to build upon some rules that we have with integration. So first things first is that the integral of sine x is equal to negative cosine x plus c, and the integral of cosine x is equal to, I believe it will be negative sine x. Right, so cosine x, oh no, so the integral of cosine x is going to be sine x plus c, and then the integral of sine x, is going to be negative cosine x plus c. Right, because if we differentiate sine x, then we get cosine x. If we differentiate negative cosine x, we get sine x. Okay, so these are just a couple of the rules that we kind of need to know. And we have the integral as well of e to the power of x, and that's just going to be e to the x. Okay, if we differentiate e to the x, we just get e to the x. Okay, so now we can just go ahead and break this down in the same way that we broke it down here, right, using the constant multiple rule. So it's just going to be 15 times the integral of sine x dx plus 3 times the integral of cosine x dx plus 12 times the integral of e to the x dx minus the integral of pi dx. Okay, so now we're just going to go ahead and solve it. So we have here sine x, that's negative cosine x. So it's going to be negative 15 cosine x. The integral of cosine x is sine x plus c, so it's just going to be plus 3 sine x plus 12 times the integral of e to the power of x, so it's going to be just plus 12 e to the x minus pi x. Okay, and then we have to make sure that we add that constant c. Okay, so that there is going to be our answer. So let's go ahead and enter this and see if it's correct. Then cosine x plus 3 sine x plus 12 times e, let's see here, e to the power of x minus pi x plus c. Okay, and that is correct as well. Okay, now we're on to question 3. So it's asking us to evaluate 9x plus 1 times 3 minus x dx. Okay, so again, we've got multiples. So what we can go ahead and do is we can integrate, or wait, now we're actually going to be probably, what we could do is we could expand this out and then integrate them like that. I think that could be something that we can do. Right, so that's actually something that I'm going to do. I'm going to expand this and then I'm going to integrate. So 9x plus 1 times 3 minus x. 9x times 3, 27x. 9x times negative x, negative 9x squared. Then we have 1 times 3 plus 3 minus x. Okay, and so then what we're going to have is negative 9x squared minus, or actually it's going to be plus 26x plus 3. Okay, so now we're going to be integrating negative 9x squared plus 26x plus 3 dx. And now we can use that constant multiple rule again. So we can do negative 9 times the integral of x squared dx plus 26 times the integral of x dx plus the integral of 3 dx. And so again here, we're using that same rule. So we Cn, right, the power, and then we do x to the power of n plus 1 over n plus 1. So it's going to be negative 9 multiplied by x to the power of 3 over 3 plus 26 times x squared over 2 plus 3x plus the constant of integration. Now we simplify it down, and then we're going to get negative 3x cubed plus 13x squared plus 3x plus c. Okay, so let's see if that's correct. So negative 3x cubed plus 13x squared plus 3x plus c. Okay, so that isn't actually correct right now. Plus 13x squared plus 3x. Wait, let me try and differentiate this to see if I get back to that there. So if I was to differentiate, it would be negative 9x squared plus 26x plus 3. Okay, perhaps I've incorrectly expanded here. So 27x minus 9x squared plus 3 minus x, negative 9x squared plus 26x plus 3. Okay, so this is likely an issue then. Here, maybe I'm supposed to be using a different rule. It's negative 3x cubed plus 13x squared plus 3x plus c. Let me enter a capital C to see if it's something here. Okay, so it actually was correct. I just entered it incorrectly in the system. Okay, but there you saw that in order to check if we've done our integration correct, we can just differentiate it and see if we get back to the original equation that we were integrating. So that was actually correct, but I had just entered it incorrectly in the system. Okay, so now they're giving us a little bit more of a tricky problem. So it's the integral of 160x cubed plus 105x squared over x to the 4 dx. Okay. So this is a little bit more of a tricky one. Now, I'm kind of just wanting to write it out again in the same form, like where it's I guess, how can we write this? Okay, actually, yeah, this is what we do. So I'm going to write it as 160x cubed over x to the 4 dx plus 105x squared over x to the 4 dx. Right, that's the exact same thing. Okay, and I'm going to quickly do a very simple example. So let's say we had 3 plus 8 over 4. Okay, 3 plus 8 over 4 is 11 over 4. That is the same as 3 over 4 plus 8 over 4. Let's check. So 3 over 4 plus 8 over 4. That is correct, okay? So here, what I did then was I broke it down into, I sort of skipped a step, because what I should have written first, to make it clear, is 160x cubed over x to the power of 4 plus 105x squared over x4 dx. And then from there, we can use the sum rule, okay, where if we have two separate sort of equations or two separate values, functions, I guess, within the integral, then we can break them down into two separate integrals like that. So now it becomes a little bit easier, right? Straight away, I can see, well, this is going to cancel out. So it's just going to be equal to the integral of 160 over x plus the integral of 105 over x squared. Okay, and now here, what I'm seeing is I can use the constant multiple rule. So it's going to be 160 times the integral of 1 over x dx plus 105 times the integral of x to the negative 2 dx. Now, integrating 1 over x, we have to make sure that x is not equal to 0, right? Because if you had x is equal to 0, this is undefined. And when we do integrate, right, it's one of the rules. When you integrate 1 over x, x must not be equal to 0. And then when you get ln of x, you must put the modulus sign, because you can't take the natural log of a negative number, right? It's impossible. So we have to be careful here when we are integrating, but what it's going to be is 160 times ln modulus of x plus, and so here it's negative 2. So negative 2 plus 1 is going to be negative 1. So it's going to be 105 times x to the power of negative 1 over negative 1. So now we're going to have 160 times the natural log of x. We have to put the plus c. Make sure you don't forget it. 160 ln x. And then it's going to be minus 105 over x plus c, right? X to the negative 1 is the same as 105 over x. Okay, so now I'm going to go ahead and I'm going to write that in as my answer. So 160 times the natural log of modulus, right? We have to make sure, if I can find the modulus sign here, where would that be? Okay, I'm going to just leave it there as ln x, minus fraction 105 over x plus c. Okay, so let's see if we've got that correct. Okay, so that isn't yet correct, but I feel as though it may just be an issue with how I'm writing the ln x. Okay, let me quickly check here. So, and let's put the ln x sign, modulus sign. Okay, so there, I didn't put the modulus sign because I couldn't find it, but then I just entered it with lines, with vertical bars, and that worked. Okay, so that's the correct answer there. Okay, and then that's all of the questions done. So I think it was important as well to see here, right? After you integrate, if you then want to check that you've done your answer correct, just differentiate your final integration and see if you've got the original equation that you were integrating. So that's it for this video. Thank you very much for watching. I hope it does help you guys, and have a good day. Bye-bye.